We're going to look at logarithmic expressions and how we can condense them or expand them. So first, there are three rules to know. Three rules. The first one is called the product property. Okay. Property. And the product property is basically the idea that multiplication leads to adding, or that adding leads to multiplication. And I'll show you how that works. Okay. So I'm going to do two things. First, I'm going to take log base 4 of 8 plus log base 4 of 3. And then next to it, I'm going to be doing a B1. Actually, I don't need to go so far here. So if you're taking notes, just try to follow along with what I'm doing here. This log base 4 of 8 plus log base 4 of 3 is equal to log base 4 of 8 times 3. So see what's happening here is that because this is adding, let me get that back there, because that's adding, if it can be multiplication, so it's like that can become multiplication, but notice that the log base 4s sort of merge together. In other words, you're putting together two log base 4s, which you're allowed to do if they're the same base. Ooh, important point. Must be same base. Ooh, now that's hard to read, so let me go like this. Oh, I am going to win, so hold on a minute and let me win that. Okay. Must be same base. So this is a nice rule, but it must be the same base. So what I just did here is I condensed. I condensed this one and made it into this one, which actually isn't completed. I made it into this one, which then makes it into log base 4 of 24. Now let's do one where it's expand. And that's going to be the B one here. For B, I'm going to do log base 4. I think I like G that way. Okay, that's better, G, of the number 36. So there are numerous ways we can write 36. I'm going to choose this one. So, well, actually, it's right up here. This is 36. You can write this as 2 times 18, as 3 times 12, as 4 times 9, as 6 times 6. All those different ways. I'm going to choose one of those. I'm going to choose this as log. Get this more easily readable for you. I'm going to get this as 12 times 3. Any one of those work here. Okay, but I'm going to choose this one. Okay, and so then that means it's log base 4 of 12 plus log base 4 of 3. So notice that minus, whoops, or no, that times becomes plus, but then the log base 4 you get twice. So you're splitting it up. Split up. Okay, if base is the same. And notice this is where I said that we went from plus to multiplication. And here we're going from multiplication to plus. That's what happens for the product property. Now, there are two other properties. One of them is almost like the opposite of this, okay? And that one's called the quotient property. It's the same concept you're going to see here. Property. Right. So the quotient property is going to be using division, as you can guess, and subtraction. We're going to do the opposite. We're going to have division becoming subtraction and subtraction becoming division. Yeah, that's better. Let's do a condensing now. And we're going to do an A just like above and a B just like above for an expand. And let's use the same numbers for this one. Log base 4, 8, but now it's going to be subtract instead of add. Log base 4, 3. Then following this kind of a rule, it's going to be log base 4 of 8 over 3. So what we're doing is the subtraction becomes the division, but then this log of that log condense or combine together to condense. Okay? And then the 8 over 3, if it wasn't going to come to a decimal, I would simplify it, but this one I really shouldn't. We just need to leave it like that. So equals, then that's checked, that's done there. Just like this one's the answer for that. I think I should do this. Okay. So those are the results of doing these. And over here for expanding, we're going to take log base 4 of 36. And again now, we're going to expand by using the numbers of 36. So that could be written as 18 over 2, or as 12 over 3, or as 9 over 4. Oh, no, I'm wrong on here. That would be times it. I am doing the opposite of that. I have to think of bigger numbers that'll make 36. So let's take a couple simple ones. 72 over 2, that would make 36. How about I multiply them both by 10, 360 divided by 10, because I'm thinking of this as 36 over 1. Right? So 72 over 2, 360 over 10. There's lots of choices there. If I multiplied by 3, let's see, that would be 90, 108 over 3. So any of those would work. I'm going to choose the first one and say this is going to be log base 4 of 72 over 2. And so that would be the result of expanding it. Okay, well, let's get that back there. Now the third rule. Third rule is called the power property. And this one's actually really easy to get and understand and is actually very common, maybe even more common than the other two. You use it more often in some different things. I'm sorry, I'm going to get this. There, I got that. Now, let's do two ways of showing the power property. Okay? And you'll see what happens with it. A, 2 log base 5 of, say, the number 3. And then here, for B, we're going to do log base 7 with a 25. Okay. So I'm going to take the coefficient that's in front and put it to the power. This becomes as the power. That's going to be log base 5 of 3 squared, which is log base 5 with the number 9. Over here, we write this as log base 7 of 5 squared, and then that exponent is going to go in front, making it 2 log base 7 of 5. In other words, the exponent and the coefficient can be switched. Okay, that can be moved back and forth. Coefficient, in fact, we can say it equals. Coefficient equals the exponent. And so you can move them back and forth like that. So that's going to come in very handy for solving a couple of certain problems with that. Now let's take a look though at doing some condensing and expanding problems. Okay, so I'm going to do a set of condensing problems. So let's do 3 natural log x. I'm purposely doing it with natural log to show you can do the same rules here with it. And natural log of, and I should do that with my L like this so it doesn't look like a 1. Natural log of x squared minus 25. And then I'm going to do it with plus 3 natural log of x plus natural log of x squared minus 25. Right? So here, because that's minus, I would want to put this in dividing, but first we have to take care of that. In other words, you cannot do the the power property or the quotient property unless there's no coefficient in front. So that means our first thing is to do that. So we get natural log of x to the third power and natural log of x squared minus 25. Now, since neither of them have coefficients, we can go ahead and do natural log, which we don't know going to put the a. So we could do, if we wanted to, we can make that log base e. But I'm just going to follow with the beginning of natural log. That's going to be natural log of x cubed over x squared minus 25. Now we could do x minus 5 and x plus 5 in place of the x squared minus 25, but there's no need to because the x to the third doesn't go into that. So if there was a different thing there, I might do it in order to cancel something, but no, I'm just going to say not needed. So we don't need to factor that because it doesn't do any good for us. However, what I've just done is I've condensed it. Probably disappear. So bring it back. Oh, get back there. Want that. I don't want it all to disappear. Sorry, I'm going to get it. I'm going to beat this. And I'm going to beat this, whether it likes it or not. There, I have done enough of it. Okay, now on the other one, there's a little more to do. Okay. The other one, though, is a plus. So instead of dividing, I'll do subtracting. Or not, instead of dividing, I'll be doing multiplying. So first, we have to rewrite this as natural log x to the third power, taking care of that, plus natural log of x squared minus 25. Now we can put this together as natural log of x cubed times x squared minus 25. Now we can do some multiplying of that out. We can distribute that so we get natural log of x to the fifth power because we're going to add those exponents. We have x cubed times x squared, so therefore it's 3 plus 2, minus 25x to the third power. And in parentheses there. If we don't put the parentheses, it's going to look like it's just natural log of x to the fifth, then subtract the number 25 times x cubed, not as a natural log. So you have to be careful to put parentheses to clarify that. And that's as far as we can go. There's nothing more we can do here with this one. But what we have done is we've condensed it. All right. And now let's look at expanding. This is condensing that we just did. Now let's look at some expanding. Expanding. There's a real G. Okay, so for expanding now, nope, I'm going to just circle that actually in red. So for expanding, let's use this. I'm going to have a nice big example one, log base 7. And way in parentheses, we're going to do dividing. And on top, it's going to be cube root of x, and then y to the 4th, and the denominator is z to the 5th power. All right. There are numerous things we're going to do. We're going to have to take care of the fact this is dividing. We're going to have to take care of this cube root. We're going to have to take care of that 4th power and that 5th power. So that's like 4 different things we're going to have to do. And the first one is take care of that. Okay. And what I'm going to do, and then actually something else I should mention is there's multiplication in there. That will be the second thing that we take care of. And I'm going to make that 2 more there. And then we're going to have choices on the others. Okay, so we actually, this will be the third thing that we deal with, is the cube root. And then 4th is those, and they can be dealt with or sort of at the same time. Okay, so there's at least 4 steps to do. So the first thing we're going to do is we're going to take care of the division part. Log base 7 is going of cube root of x, y to the 4th, subtract log base 7 of z to the 5th. It wouldn't be good to take care of this number 2 part that I mentioned first because it's inside it. We need to take care of like bigger thing, break it up first. So now the second thing we'll do is we'll deal with the multiplication part that would have been there. So it's going to be log base 7 of the cube root, maybe do that right to get that cube in there, times log base 7 of y to the 4th minus log base 7 of z to the 5th. Okay, so this one has now been split into 2 things. Okay, and now we have 3 of them. Whoops, that x went away there. So third, I'm going to do log base 7 as x to the 1/3 power. Remember that a cube root is a 1/3 exponent power, right? That's one of those little, remember your lessons in the past on roots, and make that you can make them fractions like that. Right. So as a reminder, the square root of 7 can be written as 7 to the 1/2 power. So we'll usually write the 2 there, but the root number becomes the denominator of a fractional exponent. Well, I just took care of that. And in fact, I won't do the next step yet. Log base 7 y to the 4th minus log base 7 z to the 5th. Now, let's simultaneously take care of each of those exponents, and they all go in front of their respective separate little things. Oh, I made a mistake and forgot something. Let's fix that right now. Because this was times, it's plus here, not times. I just kept the little times dot when I shouldn't have, and that was a mistake. I apologize. So please, if you're writing notes on this, go back and fix it and put the pluses there. Now we're going to take each of those exponents and put them in front. 1/3 log base 7 plus 4 log base 7y. Oh, I forgot to put the x here. Okay. Minus 5 log base 7 of z. And that's our final answer because we've done everything that we could possibly do up to this point. Right. Now, let's look at another couple of problems as examples. So this is practice. And I'm going to give two problems. One expand and one condense. Okay. I'm going to make that X a little more fill in the space kind. Okay, so here is the expansion problem. Log base 6, the fifth root of x squared, y to the third over z to the fourth. All that in parentheses. And for condensing, I'm going to do 4 log base 3 x minus 7 minus 4 log base 3 x plus 1. Oh, I want more space over here on those. So I'm going to give you a few moments to do this yourself and then come back here, pause the video, do as much as you can, come back here and see what I do. And I'll start talking in a couple of seconds, but by then you'll be back from having paused the video, done the problems, and then you can see. Okay, let's now show with the expansion one. So first I'll take care of the division. So it's log base 4, and it's going to be the fifth root of x squared y to the cubed minus log base 4 of z to the fourth. Now I'm going to do the multiplication part of those. So it's log base 4, fifth root of x squared plus log base 4 y cubed minus log base 4 z to the fourth. Well, let's now look at the fact that we have this. We're going to rewrite it and make that a fractional exponent, log base 4 x to the 2 over 5 plus log base 4 of y cubed minus log base 4 of z to the fourth. Well, let's bring each of those exponents down in front as coefficients. Log base 4x plus, oh, I apologize. For some reason, I wrote a 4 there, and I don't know why I was writing that one. It's supposed to be a 3 from that. So that means it's a 3 log base 4y minus, now this 4 looks correct here, 4 log base 4z. So if you missed one part of that, then you can fix it yourself. But now think carefully about each of those things that I had to do, including and especially the exponential fraction. Most people don't think about that for the square roots. So that's an important thing now to see that you can do here. All right, now let's look at condensing. So in the condensing thing, the first thing we're going to do is take care of those exponents. So it's log base 3 of x minus 7 to the fourth power minus log base 3 of x plus 1 to the fourth power. So now I'm going to be able, because that's minus, we're going to do log base 3, and it's going to be in parentheses with the division symbol, x minus 7, or the line that signifies that, x plus 1 that signifies division. So this is okay, but better as, look at what I do here. Oh, I want to do the L's, my L's like that. Log base 3 of x minus 7 over x plus 1 brought to the fourth. So that's considered better condensed or more condensed. Okay. back to size. Larger is okay, but this needs to be a little bit better sized. Okay. We could put the extra double parentheses in there, we don't need to. So that one is about as condensed as we can make it. All right, so to review the main things from this that we just went through is, okay, is that there are three rules: product property, quotient property, and power property. Make sure you recognize each one of them when you see the pluses, the times, the minus, the divide, and then that condensing and expanding, you use all of those properties to do it. Only those three properties, actually, but all of those three properties. I guess I shouldn't say only because of the fact that there's this kind of a rule too that you have to do, right? As well as this kind of thing to do the four there. Well, there was a lot in this one, but if you apply those three rules, you can do any expanding or condensing, but just pay attention to the details of it. I hope this helped with understanding all this better. Thank you for watching and listening.